In our previous lectures, we've already seen how a line can be represented in the standard form as ax plus by equals c. And we were able to take an equation that was in this form and create a table of values and plot the points. Well, let's do that again now with this equation right here. Negative 2x plus y is equal to 5. Only I'm going to add 2x to both sides so that I can get y equal to 5 plus 2x. And just because I'm trying to show you something, that's why I'm doing it. Now, it's also actually going to help us when we create a table of values. If I choose my values for x, I can then plug them into 5 plus 2x to find out what y is going to be. Now I'm going to go against what I have said in the previous lectures, and just for the purposes of this example, I'm going to choose values as negative 2, negative 1, and 0. Okay? And when I plug in values of negative 2 into this equation right here, I see that 5 plus 2 times negative 2 is going to be equal to, that's 5 plus negative 4 would be positive 1. Okay, let's do that again. 5 plus 2 times negative 1, well, that's 5 plus negative 2 would give me a positive 3. And this is 5 plus 2 times 0, well, that gives me 5. So I'm going to rewrite my y values over here on the right-hand side. What do I notice while I'm on this table? What do you notice as I move from one y value to the next y value? As I move this direction, what is the difference in those y's? Well, to get from a 1 to a 3, I have to add 2. To get from 3 to 5, I have to add 2. I could keep on going, but each time I move from one y to the next, I'm going to have to add 2 to it. Let's see what happens when I move from 1x to the next. When I move in that direction, if I go from a negative 2 to a negative 1, I've increased by 1. When I move from negative 1 to 0, I have increased by 1 again. I've increased by 1. So this is actually representing my slope. Remember that slope is going to be the change in the y's over the change in the x's. In order to change from one y to the next, it's 2. And in order to change from one x to the next, it's 1, 2 over 1. And I'm going to keep that in mind in just a second. Now, I do want to come over here though and highlight. I have the point negative 2, 1. Okay, I have the point negative 2, 1, negative 1, 3, and 0, 5. And I'm going to go plot these 3 points over here on my line. Okay, so I'm going to go over 0, up 1, 2, 3, 4, 5, all the way to the top. Okay, I am going to plot negative 1, 3, so I'm going to go negative 1, up 1, 2, 3. And then the next one I'm going to plot is negative 2, up 1. So negative 2, up 1. And I have a straight line that I can draw here. Now, if I wanted to look at my points on this line and I wanted to count the slope, you can see that the slope here is the rise over the run, isn't it? I'm going to rise 2 and I'm going to run 1. I'm going to rise 2 and run 1. Just like we said here that the slope was 2 over 1. Now, where is my line crossing the y-axis? It's crossing at 0, 5. So I want to highlight for you 2 things in this. It is no coincidence that when I took this equation and turned it into this equation where y is equal to 5 plus 2x, this 2 happens to be the slope. And this 5 happens to be the intercept. Okay, so what we get out of that is y equals mx plus b. We now call this the slope-intercept form. So y is equal to some number times x. Here I have some number times x plus a constant. And in this case it was 5 plus a constant. And this is going to be our new equation that we're studying this lecture, called the slope-intercept form. And we're going to use that equation to be able to graph rather quickly